Let's take a look at what we're talking about when we say exponents. Now, most of you are familiar with the term exponents, but you might not know what the basic pieces are made up of. 2 to the power of 3 really has 2 numbers in it. The 2 is what we call the base, and the 3 is actually the exponent. It's the little number that's written up higher. Now, 2 to the power of 3 actually means that we're going to take 2 and multiply it 3 times. An exponent tells us how many times to multiply the base. So 2 to the power of 3 is really 2 times 2 times 2, or 8. What if it was a fraction, though? Let's take another example. What if we had 2/3, and all of that was raised to the power of 2? Well, there's 2 ways to think about this. 2/3 is really the same thing as, or 2/3 squared is really the same thing as 2/3 times 2/3. We can multiply numerators 2 times 2 and multiply denominators 3 times 3, and we come up with 4/9. Everything inside parentheses was squared. There's another way that it can be thought about, and usually this is a little bit easier in algebra, is we take each component of that fraction and we raise it to the power of 2. In other words, it's the same as saying 2 squared over 3 squared. As you can see, it's the same. It would work out to be the exact same number, because when we say 2 squared, well, 2 squared is 2 times 2, or 4. 3 squared is 3 times 3, or 9. And both of the answers are the same. Algebraically speaking, though, it's a little bit easier for us to do the second one. Now let's take some other examples and see what we mean when we say write something in exponential notation. Exponential notation tells us to use exponents. In other words, they don't want us to multiply all these numbers out. Example 1 is 5 times 5 times 5 times 5. The base is going to be 5. The exponent would be 4. In other words, it would be 5 raised to the power of 4. Let's look at example 2. We have 6's, and we have 1, 2, 3, 4, 5, 6, 7 6's. So our base is going to be 6. Our exponent is going to be 7. Exponential notation, 6 to the power of 7. Example 3 has 2 different numbers, so we'll have to have 2 different bases. In other words, we're going to have 4, and that's going to be squared, 2 4's, right? 4 times 4. And then we're going to multiply that times 3 3's. So we have 2 bases, 4 and 3. The 4 is multiplied twice, and the 3 is multiplied 3 times. So we would write that with 2 numbers and 2 different exponents. Example 4 has a 7, which is only written once, so we don't have to have an exponent. Anytime we have a number without an exponent, we understand that the exponent is 1. In other words, the base only gets multiplied 1 time. The 4 is we have 3 4's, so we'll say 4 times 4 times 4 is 4 to the power of 3, or 4 cubed. Now let's take a look at evaluating some of the answers. When we evaluate the answer, they actually want us to find out what the answer will be when we multiply. So let's look at example 5, and what we have is 6 squared, which is 6 times 6. If we evaluate that, we're going to multiply the 2 together, and our answer is 36. Example number 6, we're going to have to write 3 5 times. 3 times 3 times 3 times 3 times 3 times 3. Now, when I multiply 5 3's, I have to really think about it. I would probably multiply 3 times 3 and get 9, and then multiply 3 times 3 again and get 9, and then I'm going to multiply that 9 times 3. I'm just going to shortcut it. Then what I would do is say 9 times 9 is 81, and 81 times 3 will be my answer. It's not too hard for me to multiply. 3 times 1 is 3, and 3 times 8 is 24. 243. The biggest mistake we make when we use exponents, though, is looking and saying, I know it's multiplication, so my answer is 3 times 5, or 15. Well, 3 to the power of 5 is nowhere close to the number 15, as you can tell. So you just have to be careful about that. Number 7 is an exponent that doesn't really have to be written. 8 to the power of 1 is just 8. And number 8 is an easy one for us to figure out. 1 to the power of anything is just going to be the answer 1. We can multiply 1 as many times as we want to and still just come up with 1. Now I'd like to introduce you to the order of operations house at the bottom of the page. And the order of operations house is really something that I'm going to show you just to kind of keep in order which operation comes first? You've probably memorized, please excuse my dear Aunt Sally, and those are the initials that you find in the house, but please excuse my dear Aunt Sally does not take into account the fact that multiplication and division have to be done at the same time. In other words, the operation that we do first in multiplication and division is the one that we come to first in the problem. Addition and subtraction is the same way. So I put this in a house format, and the directions are very clear, and they're over to the left. You work it from the top to the bottom, left to right. In other words, if we start on the roof, we find in the roof we have parentheses. These parentheses mean that when you find parentheses in a problem, that's the first thing you do. Parentheses trumps everything, so we work those first. Second, we work our way down to the attic. Exponents. After parentheses, we would look at all the exponents in the problem, and we would resolve those exponents. We would evaluate them and figure out what they were equal to. And then next, we come to the second floor. The second floor has multiplication and division, and they are together. This is where we work it left to right. In other words, we're going to pick the operation that comes first in the problem. If it's multiplication before division, we'd work multiplication first. But if division came before multiplication, we would work division first. They're on the same level of the house. Remember, they're on the second floor. Addition and subtraction is the final set of operations we do, and we also work those left to right. Whichever one comes first, that's the operation we work first. Let's continue discussing order of operations with some more complicated examples. For example, 9. First, we just have two operations. You'll note that we have addition and we have multiplication. We'll do multiplication first. So what we have now is 24 plus 3 times 6, which is 18. All we've got to do now is to add. Now, if you're having trouble adding without your calculator, and remember, these should be able to be done without a calculator, be sure you write everything vertically instead of horizontally. 4 plus 8 would give us 12. I'd carry the 1, and when I add 1 plus 2, I get 3 plus 1. I'm going to have 4. So my answer here is 42. Example number 10 has division, and then multiplication and addition. If you note on your order of operation house, division and multiplication are on the same level. So which one do we do first? It's the one that we come to first in the problem. So we'll do division first. We'll say 100 divided by 10. That gives us 10. Just write the rest of the problem down. Let's just try handling one operation at a time. The next one we need to handle is going to be multiplication, because all we have left is multiplication and addition. So 10 times 5 would give us 50. We'll write the rest of the problem down, and now we only have one operation, 50 plus 4, which gives us the answer of 54. Example number 11 really has two operations. Sometimes we don't recognize a fraction as a division problem, but that's what it is. So we have addition and we have division. Of course, we handle division before addition, so we'll say 32 plus 8 divided by 2, which is 4. Now we only have one operation, so 32 plus 4 is the 36. Example 12 has multiplication, addition, and multiplication. Now, as we're going through this problem, we could just do one operation at a time. Multiplication, the first one we come to, is 3 times 4. So that would be 12 plus 9 times 1. Now we still have one multiplication operation. We'll need to do that before we can do the addition. And now we can finally add 12 plus 9 for 21. Example 11 is a unique problem because it is a fraction. It has a complicated numerator and a complicated denominator. So we handle them each separately until we have just one number in the numerator and one in the denominator. Then we do the division. This is the only time that division sort of steps out of order when we're talking order of operations. So let's look at this first. The numerator all by itself. We have two operations, addition and division, so we'll do division first. Now our problem says 6 plus 9 divided by 3, which is 3. Now that's all we'll do right now in the numerator. Let's look at the denominator, and we have an exponent. So we can say 3 times 3 is 9. Now let's take our numerator next, and we'll do addition up there. 6 plus 3 is 9. And now we have 9 divided by 9, which, you know, anything divided by itself is really the whole number 1. I want to look at example number 14. It's fairly complicated. We have exponents and multiplication, and parentheses, and then we have inside parentheses, we have subtraction. Then we have addition, another exponent, addition, and another exponent. So what do we have first? What do we handle first? Well, parentheses trumps everything. So inside parentheses, I only see one operation, subtraction. I'm going to handle that first. Everything else, I'm just going to write it down so I don't get confused. So I'm going to say 5 squared times 10 minus 8 is 2. Now I don't need parentheses anymore. There's only one thing in there, and I've already got the multiplication sign, the dot, so I don't need that either. Everything else I'm just copying down. Next, I'm going to handle my exponents because they're the next highest order. So 5 squared is 5 times 5, which is 25. I'll leave the times 2, and then I'm going to say plus 2 cubed, which is 2 times 2 times 2, and I know that's 8, plus 5 squared again, once again 25. Now I'm down to 3 operations, multiplication, addition, and addition. Multiplication is the highest. I'll do it first. And I'm just going to write everything else down. Now since they're all addition, I can very easily add the first two. 50 plus 8 is 58, plus 25. And once again, I might need to come over here and write them vertically so that I can add without making a mistake. 8 plus 5 is 13, carry my 1. 5 and 1 is 6, plus 2 is 7. Rather 8. There we go. And so the answer is 83. Let's try a similar problem where we have a complicated numerator, a complicated denominator, and we'll handle them as 2 separate problems. Then we'll put them together finally for the final division problem. Example 15 has parentheses, multiplication, and subtraction in the numerator. We're only going to do parentheses first, so we'll write down 5 times, and we'll say 12 minus 7 is 5. That's the only operation in parentheses, minus 4. The denominator has exponents as our highest operation, so we'll say 5 squared is 25, and everything else we just write down. Next step is going to be handle the highest operation in the numerator. Well, that's going to be the multiplication between 5 and 5, so I'll say this is equal to 25 minus 4. In my denominator, what I have to do is say 25 minus 18, and I know that's the number 7. So now in my numerator, I've simplified it down to one operation. 25 minus 4 is 21. The denominator is 7. Finally, I get to do the final operation, which is combining the numerator and denominator and handling the division, which is 21 divided by 7, or 3. Now, example number 16 says 18 minus 7 divided by 0. And I note that part of this problem is division by 0. Now remember, anytime you try to divide by 0, it's really not allowed. If I write that as a fraction, 7 divided by 0, I can form the word no. If I put the 0 next to the letter O, it'll form the word no. I'll put the N next to the number. In other words, that means that anything that divides by 0 is undefined. So if I have division by 0 in my problem, the entire problem, the answer, is undefined. I really can't come up with a solution. Now number 17, let's see how complicated we can get. We have 1, 2, 3 sets of parentheses here. We're going to just work innermost parentheses first. We're going to handle 3 plus 5. And just for simplicity's sake, I'm going to write the rest of the problem down just like it is and only do the one step at a time. So inside these brackets, I do 3 plus 5. Which is going to be 8, and everything else just stays the same. Now I've got 2 sets of parentheses. Well, since they're separate sets of parentheses, I can handle them together. 18 divided by 6 is 3, and then the next set says 8 plus 2 is 16. I'm down to one operation, 3 plus 16. My answer is 19. Now another fairly complicated one is example number 18. In other words, when we have 3 sets of parentheses and they're all nested, they're inside each other, you can only do one at a time, the innermost set of parentheses. Everything else, we'll just write it down, being careful that we don't make any mistakes, leave everything the same. So I'm going to say 10 minus 8 is 2. It's going to be multiplied times 8. I've got my multiplication sign there. I've gotten rid of that one set of parentheses, but I'm keeping the other two. Now I'm going to do the innermost set of parentheses again. So all I'm going to do is 8 times 2. Everything else, I'm just going to write down so I don't make any mistakes. So this time I have to keep that set of parentheses to show that I need to multiply the 3 times whatever's inside there. 8 times 2, of course, is 16. And everything else I will write down. Next, inside my parentheses, I have the operations addition, multiplication, and subtraction. Well, I'm just going to handle multiplication first since it's the highest order. I'm just very careful to write everything the same. I'm going to say 3 times 16 is going to be 48. All my other operations stay the same. Now inside parentheses, I have addition and subtraction. I can do those in the order that I see them in the problem. So I'll say 5 plus 48 is going to give me 53. And in my next step, I'll handle the last operation in parentheses, which is 53 minus 20. And 53 minus 20 is going to give me 33. Now I no longer need the parentheses since there's only one term in there. And I have the final operation, 39 minus 33, and my answer is 6.